A really important conceptual point is that waves transfer energy. And this is when we have to think about energy in a very general sense, the ability to do work, for instance. And think about your source is actually putting energy into the medium. And for instance, your source might be the sun giving off electromagnetic waves. Your source might be a speaker that is moving back and forth. So there's some source of energy in literally the source, but then it is being transformed into that wave through a process that we're not going to worry about in detail right now. We're talking about it in general. Now then the wave moves from point A to point B, if we think about a traveling wave, and you actually have energy then going, right? Imagine that the sun turned on in the morning. It had been, sleeping. Well, then light would come from the sun and eventually reach us. It would take a little bit of time, I think about 8 minutes for the light to get to us. So we then would have that energy. And you know that we have solar panels all over campus. We can take solar energy that was transmitted to us as electromagnetic waves and do stuff with it. Run your hair dryer, run a toaster. Now, one thing to note is that most media are dispersive, which means energy is lost. So for instance, if I have a speaker that's putting energy into the air, some of that energy is just being turned into heating up the air, actually, but it's fairly little. We are going to ignore this. So one of the simplifications that we make when we think about energy and power in waves is that all of our energy and power is being transmitted in the wave itself. We're not thinking about like water waves just warming up the water a little bit. So there are some effects there, but we don't consider them in this class. We're going to consider them negligible, which is a good approximation. Now the last thing to remember is that if we want to talk about power, that's just energy divided by time. So it's the rate, right, or say the rate of energy, dE dt, that again is being detected or that's being put in to our wave. So we frequently talk about power. So if we want to talk about intensity, that is normalizing our power by the area that the wave is going into. So a simple thing would be thinking about just a rectangular surface with area A. If we have a bunch of plane waves, the power is just then going to be divided by the area and you get your intensity. Now, if we have a spherical wave, you have the power of your source. So normally we know the power that's going into the wave. And then this is how far you are from your source. So the distance from the source. And so this is just then the surface area of a sphere. So again, in this case, it's a spherical wave. So as you get further and further away, your power has been distributed on the surface of a sphere with a bigger and bigger radius. So as you get further and further from your source, the intensity goes as 1 over r squared. And that's simply basically dividing by the surface area of a sphere. Now, one thing that's noted in the book, it might come up once or twice, but so there's not that much to do with it right now, is that intensity is proportional to the amplitude squared. So if I say that my amplitude is A, then another way of writing this is that intensity is proportional to amplitude squared. So if I double the amplitude, which is the maximum displacement of my wave, you now actually have 4 times the intensity. So again, the proportionality here is going to be something that we can drop when we talk about the details of electromagnetic waves, and we can talk about power and energy and intensity in much more detail. So the proportionality is true in general, and then the type of wave we're talking about allows us to make this relationship a little more specific. Now, intensity here, we can just think about watts over an area, so like watts per meter squared. We can talk about ratios of intensities using decibels. And so if you see the term decibel, which gets abbreviated as dB, that is in a way a unit of sound intensity. We're just not going to talk about that. Decibels can be really tricky to understand. They're pretty complicated, and they're really not going to come up that often. So instead of like really feeling like you have a headache and you spent half an hour understanding these things and you'll never see them again, we're just not going to cover it, but recognize that decibel is something you might see related to the intensity of a sound, and it's relates to the ratio, but it's in base 10, which or log 10, which makes it confusing.